Everybody, and welcome back to another fun and exciting pre-algebra class. Today we will be in lesson 8.3, and that's going to be found on page 375. That's where we'll start, page 375. Today we're going to be talking about permutations. What is a permutation? All right, well, let's look down here at the book. Let's look at the screen, and I've got it written down. It says a permutation is the order in which objects can be arranged. So, for example, when we put things in order, that's called a permutation. Now, here's an example. If there are 3 marbles in a jar, okay, so think about, we're back to the marble idea. There's 3 marbles inside of this jar. How many different ways? Let's say that there's a different color. This example says there's 1 red marble, there's 1 blue marble, and it says that there is 1 yellow marble. So there's 3 different color marbles inside the jar. How many different ways can I stick my hand in there and pull it out? Okay, what can I get out? So the first way to stick my hand in there and pull something out would be maybe to get a red marble. So if I get the red marble first, all right, now I take the marble and I put it away, right? I don't put it back in. Now how many marbles are left in there? There's 2 marbles left in there. So I stick my hand back in there, and now I can only pull out a blue or a yellow. Let's say I pull out a blue one next, and I put that one to the side. Now what can I pull out? Well, the only thing left is the yellow marble. So in that case, I pulled out a red, blue, yellow. But let's say that I pull out a red marble first, and then I pull out the yellow marble second. Well, now all that's left in there is the blue marble. So the order that I can pull out the marbles is based on what? Well, what's left in there. Okay, so the first time I could pull out 1 of 3, the second time I could pull out 1 of 2, and the last time I can pull out 1 of 1. I can just pull out the one that's in there. So in this case, we would have a red, yellow, blue. That would be 1. A red, blue, yellow. That would be 2. A blue, red, yellow. A blue, yellow, red. And a yellow, red, blue. And then a yellow, blue, red. So this would be 1 way, right, that we could pull it out. This would be 2 different ways. This would be 3, 4, 5, 6 different ways that we could pull out a different order of marbles. So the permutation, there would be 6 permutations on this one. 6 different orders that I could pull out a marble. Okay? Now, the way that we do that, the way that we can do that without counting them, is we can just put it into a little formula. The formula is just multiplying them together. So, in other words, on the first draw, there's 3 marbles in there. That's the first draw. On the second draw, there's 2 marbles in there. That's the second draw. And on the third, there is only 1 remaining. And that would be the third one right there. So the first draw, there's 3. The second draw, there's 2. And the third draw, there's 1. The way that we would do that is we would just multiply that together. 3 times 2 times 1 is 6. Now, there is a unique and special way that we can kind of write this. Okay, so this has a name. Okay, and you probably haven't learned this name yet. This may be the first time that you learn this. Look down there. The word is factorial. Factorial. The product of decreasing factors written as the highest factor with an exclamation point. So let's go back here to this one right here. The way that we would write this, the highest factor is 3. And it would be 3 exclamation point. That's the way that we write 3 factorial. Okay, now what that means, here's what that means. That means 3 times 2 times 1. That's what that means. 3 factorial, 3 times 2 times 1. And then that's going to equal 6, right? So there's our answer right there. So we could also write this P equals 3 factorial. 3 exclamation point. All right, so let's do a couple more of these so we can kind of practice this concept of how to write these with the exclamation point. So 5 is written 5 exclamation point, and it means 5 times 4 times 3 times 2 times 1. So you can go ahead and just multiply that, and it should give you 120. Let's try it. So 5 times 4 is going to give us 20. 20 times 3 is going to give us 60. 60 times 2 is going to give us our 120. And then obviously times 1 keeps it at 120. So there's 120. You can also get calculators that do this, but at this level, I would just rather you do it, you just multiply it out. You don't need to be using a scientific calculator that has factorial on there. Just multiply it out, even if that means coming to your regular basic calculator and just doing it like that. So 5 times 4 times 3 times 2 equals 120. So you can do it on your regular calculator. I'm okay with that. I'd rather just have you do it, by hand, just from your mental math abilities. But if you need to use a calculator, or if it's just a little bit easier, it's okay at this point. But that's how you do factorial. All right, let's use this example. If 6 soccer players are racing to the other end of the field, how many possible finishing orders are there? So you got 6 soccer players just run into the other side of the field. And so we have 6 people, right, running. And so they could finish in different, orders. So Bob could finish first, and Ken could finish second, and Sally could finish third, okay? And so on. So we could have different finishers, or Sally could finish first, and Frank could finish second, okay? And so there's different ways that this can be done, the finishing order. How do we do that? Well, what we want to do, because remember, what does permutation mean? Permutation is the order in which objects can be arranged. So the order in which we can arrange those runners, those soccer players, is the permutation. How do we find the permutation? We do it with a factorial. And so that's all we would do here, is we would just do the permutation equals 6 factorial. And then we would just solve 6 factorial. And so that would be 6 times 5 times 4 times 3 times 2 times 1. We do that out. I'll use the calculator just to make it a little bit easier for you to see. So that'd be 6 times 5, and that's going to equal 30, times 4, and that's going to equal 120, times 3, that's going to equal 360, times 2, that's going to equal 720, times 1, 720 still. All right, so 720. So believe it or not, there could be 720 different finishing orders with 6 people. And it's kind of cool, right? So if you add 7 people, like look how this works. So if we add 7 people, we just do times 7, and that equals, now there's 5,000 different ways. Times 8, now there's 40,000 different ways that they could finish. All right, so this gets really big really fast because you keep just multiplying, and when you're using factorial, it gets really big really fast. Okay, so that would be how many different ways that 6 players could finish. Now, sometimes we don't need all of the numbers, okay? Because look at this case. What if only the top 3 places mattered? So this is our race again. We have 6 people racing, but only thing that matters is the first through third place. So in this case, we have 6 people racing, but only first through, well, I'll write it like this, first through third matters. So there's only 3 places that matter, right? Okay, but we have 6 people racing. So we really kind of have 2 different things going on here. This is where the formula for permutations come in. So let's go over that real quick. It is kind of in your book and kind of not in your book. So I just want to add just a little bit to this so that you can understand what exactly it is. The permutation is the N and the R. All right, you're like, what is an N and what is an R? An N is the number of people running, and the R is the number of people that matter. N stands for number, like the overall number, the total number, and R stands for really kind of nothing. It's just a random letter that we use, but it's basically the ones that are, if you want to think of it as rank, I guess, it's the ones that are ranking. It's the ones that matter in the overall, scope of, in this case, first through third. That's all that matters. We don't care who comes in fourth, fifth, and sixth. That's not the race. The race is first through third. There's only a prize for first through third. So the three that matter, the three that are ranking, goes there. R equals the three that matter. Okay? So the way that you would do this would look like P, the permutation of 6 and 3. The permutation of 6 and 3. Now watch how this works. The formula here is P equals the N over an N factorial over N minus R factorial. That's the way that you solve it. This is the part that the book is missing right here, in my opinion. You need to kind of understand that in order to wrap your mind around what's going to happen here, how many people, how many different orders can finish there. So just plug into this. So we'd have 6 factorial over N minus R. So make sure that that's in parentheses, and then that gets an exclamation after the parenthesis. Very important that you don't mess up where you put the parenthesis. So you'd have 6 minus 3, and so that's going to equal 6 factorial over 6 minus 3 is 3 factorial. So the reason why these parentheses are here is because you have to do that first. Don't put 6 minus 3 factorial. You have to put it in parentheses right there. Very important. All right, so here's what we're left with. We're left with 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. Now I want to show you something. Remember, we're dealing with factors here, right? Factorial. So what we can do here is we can cancel anything that's the same on the top and the bottom. Okay? And so this is going to cancel to 6 times 5 times 4 over, all of that cancels, so it's over 1, or the fraction just goes away, so it's just this. This will be our answer. So we can go to our calculator and then just solve that. So you come over here, clear this out, and you do 6 times 5 times 4, and that's going to equal, there are 120 different ways that those 6 people could finish in first, second, third place. Okay? Because now we're only worried about first, second, third place. We're not worried about everything. All right, back when it was 6 people running, right, we had a bigger number than that because we had 6 people running and we had 720 different possibilities that they could come in first through sixth. But now we're only worried about the first 3 places that matter. Okay, so when we do that, we have to cancel out the 3 places that don't matter. These 3 places do not matter, and so that all cancels out. These are the only 3 places that matter. Multiply it out, we get the answer. The permutation for this one is the permutation equals 120. There are 120 different ways that those people could finish first, second, and third place. All right, so maybe a little bit deeper lesson right there, but at the same time, if you can just kind of focus on the keys there, what a permutation is, it's the order in which people finish, what factorial means, and then what the formula is for finding the permutation. It's the number over the number minus the R, or the rank, or the order that they need to come in. And then you do that, cancel out, boom, figure it out, and you can get the permutation. Okay? If you missed anything, make sure you slide it back, watch it again. That's all I got for you. Have a good one. Bye-bye.